Hello, you're watching
Engineering.
Last time I talked about my first couple weeks in grad school, and before I start procrastinating on my videos, today I'm going to be talking about my first couple days of classes in grad school. So it's kind of funny that I just finished undergrad and I'm right back into taking classes. But yeah, I'm just going to be talking about what I think about what I've learned so far this week and kind of my trepidations for the next couple months. So right now I'm taking a thermo, an environmental engineering class, unit operations, environmental engineering, and computational methods. Alright, so basically in undergrad I've taken a couple thermal classes for my degree in chemical engineering, and so far it's been kind of like a review, a little bit fast-paced, but we're just kind of going over some of the fundamental topics. And it's kind of funny because doing the homework, it makes me really question why I was doing things in the first place. So it's kind of making me question reality, like pressure and enthalpy, and I'm like, do I really understand this anymore? So looking forward to how this turns out, because I heard that this is very challenging class, a lot of derivations from statistical mechanics and some quantum and physical chemistry. So we'll see how this goes. I heard it's very theoretical. It's funny that it's the same professor that I had for undergrad. And basically, thermo, if you're not familiar, in chemical engineering is very memey, like fugacity and all these weird correlations. It's kind of this like black box in chemical engineering students, and you just kind of have to use these equations and follow these procedures to solving these problems, but you're not really understanding why. And I think we're going to be kind of going over where these equations come from, deriving all these equations. But from what I heard from these senior PhD students, they made it seem that it's very convoluted and confusing, so we'll see how that goes. My second class is computational methods, which is using software, namely Matlab, which by the way I have a tutorial in Matlab, go check that out, check the link in the description. Okay, Matlab, which is a computational tool to do some calculations, and the reason this is useful is because you might have different types of equations that don't have traditional methods to solve, meaning they don't have an algebraic expression. So you want to use computers to help you solve that type of problem. So far, again, it's been kind of like review, but I imagine both of these classes to pick up really quickly. And I'm kind of seeing the homework is a little bit tricky, but so far so good. So far so good. We'll see how that goes. I really hope I don't regret saying any of this so far. My last class to me is quite new, environmental engineering. There's a lot of stuff from water quality and water engineering that I've never learned about, so we'll see how this goes. Specifically, this class focuses on separation processes, and I've taken the chemical engineering aspect of that, so we talk about like distillation, absorption, that kind of stuff. But I think in this course, in environmental engineering, it focuses more on the water quality of separation units. So looking forward to that because I like learning about real applications of science and stuff. So now I get to learn about the real science of how my water is purified and all that kind of stuff. Yeah, so I'm just kind of making this for myself, or if you're curious about what I'm kind of doing, feel free to ask me any questions. I'm hoping to look back at this and not regret what I'm saying, because so far it's been like mostly review. But I'm looking forward to seeing what I learn in these classes. Meanwhile, as a PhD student, I also have to attend different types of seminars. So I'm going to 3 different professors, essentially group meetings, and we have different discussions. So far, we've just had some introduction to their labs. One is in catalysis, another one is in sensors, and another is in water quality. And they're very, very interesting. There's one in particularly, so each of these topics are pretty interesting to me. Sensors, because you get to like make a real device and basically sense something in the environment, whether it's air or water. You want to sense if there's a chemical, or you want to sense if there's some kind of bacteria. So that's making sensors is what's useful to determine whether something is safe. Catalysis, so if you're not familiar with catalysis, basically it's this field of engineering where if you want to make a chemical, sometimes you have to use really high temperatures or pressures, or basically use a lot of energy and a lot of money, which is no good. and using a catalyst, another chemical, can help not only speed up that reaction but decrease the cost of energy and other types of things like temperature and heat and all that kind of stuff. But there's a lot of open questions in catalysis, so there's a lot of research going on. It's very, very fascinating. For me, I think the most fascinating is the water quality group because it's environmental engineering. So I feel kind of like a millennial thinking of the impact on society and the water quality. So water quality, so namely if you have some kind of water system, whether it's natural like a lake or even an engineering system like a pipe, as an engineer you want to assess the quality of the water. That's what the name is, water quality. And of course there's always research going on as to solving different types of problems, whether it's corrosion of the metal pipes or treating biological pathogens. For me, it'd be really amazing if I could do a PhD project using a combination of material science and its applications into water quality. So that's what I've been doing so far over the summer. I'm not sure how much I'm allowed to talk about that because it's, you know, non-published research, but yeah, basically it's really cool to be able to use nanomaterials and being able to use it to kill bad things in the water. So I really hope I get to continue that, and maybe I can talk about that in the future. Yeah, so we'll see how this goes. I've been inspired by my dude Andrew Dodson, who's a first year physics graduate student, and I kind of want to continue doing some more vlogs and videos and things like that, but you know, being a graduate student, it's starting to get a little time consuming, but yeah, I just want to do this before I get too overwhelmed. So if you have any questions, please feel free to ask me, and stick around for some more videos coming up. Don't forget to share this with your friends, family, and your dog.